Howdy, this video will cover inverse variation. Now, inverse variation, we'll be given this equation right here. x1 times y1 equals x2 times y2. Let's go ahead and solve it for y. So, solving for y, we need to divide by x1 to get rid of x. So that would give us y1 equals x2 times y2 divided by x1. That's still a little ugly, so let's go ahead and replace x2 and y2 with k. So that would give us the equation y equals k divided by x. Two important equations that we have here are the first and the last equation. The definition for inverse variation is going to be a relationship between x and y, whereas x increases, y decreases. And as x decreases, y increases. So pretty much vice versa. The following statements are equivalent. Y varies inversely as x is the same thing as saying y is inversely proportional to x. And that's the same thing as saying y equals k divided by x for some non-zero constant k. So k is going to be the constant of variation. If we're given our equation y equals k divided by x, let's go ahead and solve for our k, because k is very important. So in order to solve for k, we need to multiply both sides by x to get rid of x. So then that would give us k equals x times y. Very important. Next, tables. We know a table varies inversely if when multiplying x and y together, so x times y, we get the same constant for k. So we pretty much get k equals x times y. So again, if you have a table of x, y, so x, 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 y, 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 multiply x and y together, x times y, x times y, x times y. Those should all equal k, and if they do, and if they all equal the same thing, then that means we're going to have inverse variation. So here's our first example of a table, which we're given our x and our y values. So we need to find out what k equals, and k is going to equal x times y. So we need to multiply our y values by our x values. First row, we're going to have 5 times 2, and that's going to equal 10. Next row, we're going to have 2.5 times 4, and that'll also equal 10. Last row, 1.25 times 8 equals 10. So is this inverse variation? Yes, it is, because all of the k values equal the same thing. So therefore, k will equal 10. Next example, our x and our y values. K equals x times y. So multiply them together. So 1 times negative 2 is going to equal negative 2. Negative 4 times 1/2 equals negative 2. And 6 times negative 1 over 3 equals negative 2. So yes, this is inverse variation, and k will just equal negative 2. Now our first equation example, or word example. If y varies inversely with x equals 2 and y equals 12, then what does y equal when x equals 6? Mila, go lay down. So instead of using the y1 divided by x1 equation, we'll be using the x1 times y1 equals x2 times y2 equation. So let's write that down. So x1 times y1 equals x2 times y2. So now let's go ahead and label. Our first x will be x1, first y will be y1, and our second value will be x2. So we're going to have 2 times 12 equals 6 times y2, because we don't have a y2. So let's go ahead and solve for that. 2 times 12 is 24. So 24 equals 6 times y2. To solve for y2, we're going to divide by 6. So then y2 will just equal 4. Last word example, we're going to have our x1, y1 equals x2 and y2. And if y varies inversely with x equals 5 and y equals 8. Then what does y equal when x equals 4? So we have our x1, we have our y1, and we have our x2. Plug in and solve. So we're going to have 5 times 8 equals 4 times y2. 5 times 8 is going to be 40, equals 4 times y2. And then we're going to divide by 4 to solve for y2. 40 divided by 4 is just going to equal 10, so y2 equals 10. Last thing, inverse variation in graphs. There's going to be 2 rules. Those 2 rules are going to be, we have a curved line that never touches the x or the y axis. So let's go ahead and put our x and our y axis on the board. So our y axis and our x axis. And let me show you what our curved line that never touches the x or y axis looks like. That's going to look just like this. Okay, so we have 2 curved lines that never touch the x or the y axis. Now, how do you recognize inverse variation in a table? Well, in a table, we need our k values to equal the same thing. And with inverse variation, k equals y times x, or x times y. How do you recognize inverse variation from a graph? Simple. We're going to have a curved line that doesn't go through, that doesn't touch the x or the y axis. And then lastly, how do you recognize inverse variation from an equation? Simple. Our 2 equations for inverse variation are going to be x1, y1 equals x2, y2, and y equals k divided by x. And that's all, folks. Thanks for watching.